Let's address a few FAQs we typically get from users. The first one that we hear a lot is what a relationship between PSS and UVM, and does PSS replaces UVM? Well, PSS does not replace UVM. UVM is the recommended methodology for protocol level verification, the kind of thing you need to do with hardware verification, with fine control, reacting to signal as they change, etc. Many times UVM would be the recommended approach, and you don't need PSS on top of it. At the same time, when you look at SOCs for these kind of scenarios and use cases, you will use PSS, and you probably will call your VIP and UVM sequences on the right platforms. So you will activate them. PSS will orchestrate both programming your device and external traffic and build use cases like that. So what is the PSS value on top of UVM? Scenario solving capabilities. We've mentioned that and we've seen that in the demo. So if you have sparse configuration space, and in specific you want the traffic to depend on this configuration space, these are the kind of things that PSS does very, very efficiently. Anything related to scheduling, concurrency, legal resource allocation, goal-based scenario. Here's an action. Find a random way to make a legal solution that will run this kind of action in my test. The other thing that PSS does very, very efficiently, if you coming from a UVM background, you would probably see that where PSS is generating the virtual sequence as opposed to a human being engineer coming up with it, and of course it's coordinating things on the hardware side, traffic side, and software as well, right? So what's going on the CPUs. PSS enables automated filling of reachable coverage. So with UVM, it's a typical challenge. You get to a 95% coverage, and you don't know if the last 5% is because you didn't run enough tests, or maybe it's not reachable at all. Rewinding back on the modeling that we did on PSS, we kind of modeled all the legal behaviors, and a PSS tool can actually tell what is the legal scenario space. So PSS can tell you, hey, this scenario, this coverage is not reachable, and this is why, or this is reachable. In a goal-based approach, let me give you the solution that will hit that coverage point. So this is very efficient from the PSS point of view. Enabling reuse, we mentioned the platform's ability to create a different kind of and support different kind of target platforms. Vertical reuse, all of these are key for PSS. We've seen how we use the composer GUI, graphical notation, UML notation. The PSS standard lends itself very, very nicely into using these kind of approaches. So if you have a VIP of UVM, you don't need to learn UVM or sequences or system Verilog. You can just use a GUI for that, and that is very efficient and creates scenarios, even if you're not a hard verification experts. Multi-language support, we can generate any language, command files, UVM, C, system Verilog, any kind of data formats that might be needed. And we can also coordinate the activation of these and pass data between them. So PSS is actually a very useful multi-language solution. Let's spend a little bit of time on the adoption bar. How fast do I get to the first test? So this is a model-based approach. Wouldn't it take, a long time till I get to the first test running? So just from my experience doing many projects, typically we have non-trivial tests running in the first week. This is with the assumption that the system is up and running to begin with, and we just need to create sophisticated tests that probably too hard to achieve manually. And typically the system will be behind, and we will create a lot of scenarios and wait for the system to be ready. So how is that possible given all the modeling effort, right? So modeling is only for behavior and features that needs to be exercised. It's very, very abstract. Hopefully you've noticed that. If I'm modeling a complex display engine, I don't model all the features, all the hierarchies, the infrastructure, all of that. It's just the actions of that display that I model with a few parameters that are needed for my SoC use cases, right? So that's not as detailed as I would do with a VIP, and I will just use APIs, existing APIs, both on the software side and the test bench side, and we'll call them. Modeling is also done incrementally, so I can focus on a certain area and leave the rest of it just in one block of code. So for example, if I want to check my display, I may just turn on power on the entire system and focus on that. Later, when I do low power verification, I may refine that and change the, basically create power transitions, etc. But I don't have to focus on the full thing, and it's very flexible to enable refinements in the model itself. Once the initial model is in place, scenario creation is easy. We have the interactive approach, interactive process in which I know if it's legal or illegal before going into this expensive iteration of compiling, running, debugging, and then realizing that the test was incorrect. So this is very, very efficient process, and once you got the first test running, the model is in place, you get for free huge number of variations, huge number of use cases, very lengthy, very sophisticated, easy to control. And if there's any changes, spec changes, API changes, platform changes, as opposed to revisit and maintaining my regression, my test regression, I can just change the model or the exec blocks, the realization blocks for a specific platform, and regenerate the entire regression. So a very, very efficient paradigm. Let's talk a little bit about the PSS compliance migration and vendor independence. You've seen in my presentation that I'm using PSS DSL and I'm using C++ modeling. How do we achieve that? How do we make sure that from all these different languages I can make sense and create a single solution? Where the answer is that we're using exactly the same concept and construct. It's exactly the same language that is either encoded in a domain-specific language or encoded in a library in C++, but eventually they need to be resolved and are being resolved together. And this is where we create our solution. This is exactly what we're doing with the Cadence technology. We have a different kind of input formats and all of them resolved together. How can we ensure cross-vendor portability? We have some experience, not the best experience with System Verilog. So how can we ensure that? So the answer in the LRM, we formally cover the syntax and semantic. It's written down very, very well and in detailed approach. What is PSS and what is not PSS? So you can look at that. Some of these chapters are not for users to read, just in case you want to verify that what you're using is really PSS. I just want to say that if you go too dynamic, for example, using C++ in a way that cannot talk to the DSL, to a DSL solution, we will not be able to do the solving right at the same time. This is well defined. Now, on top of the LRM and the section that cover the semantics, we are going to provide as part of Accellera official tests examples that will be included in the standard. I have a few Cadence specific messages. This is related to our technology. I think it will be interesting to others as well. Perspec users. For many years now, you're using what we call SLN, the system level notation, and here's how it's look like. Here's a log of 2 channels. Here's an action DMA, in this case the 2-unit transfer, and I have an input data buffer from memory, output to memory, and I'm locking one of the channels, and here's constraint. This is the SLN code that you've been using for years. Here's how the PSS DSL look like, right? The pool of 2 channels, action transfer, input, output, lock, and constraint. Simple change of syntax. Even the hierarchy is the same. Here's PSS C++. Pool or DMA transfer derived from an action, constructor, input, output, lock, constraint. So you see how things came from SLN into these formats. Very easy to create an automated tool to create the conversion between them. Let's talk about the activities. Here's the audio scenario, randomizing some attribute between 1 to 5. The activity is transfer, and repeatedly ops number of times, do receive and play with some constraint. This is how it's going to look with the PSS domain specific language. Action, audio scenario, ops num 1 to 5, activity, do transfer, and repeatedly do receive and do play with constraint. C++, same thing. Audio scenario, derived from an action, constructor, we need to define the handles, ops number of time between 1 to 5, and transfer, repeat, ops number of time, receive, and play. As you can see, things are very, very similar in both structure, and you can read them together and understand and make sense. So the ones that chose Perspec are in the best position to master and migrate to the upcoming standard. Of course, you guys know all the modeling patterns that these powerful primitives can provide. How do I model interrupts? How do I model state machine? All of that knowledge that we have and all of that experience working in your environment is extremely relevant and is going to be extremely useful as you move on. Cadence PSS leadership and support. As you've seen in the previous slide, PSS concept, the major ones are incarnation of proven Perspec concept. We're talking about actions as units of behavior, the inputs and output that capture both data and control dependencies, right? So declarative resources with constraints, compound action, nested activities, concurrency, schedule, parallel, all of these, exec blocks, components with their attributes, aspect-oriented and object-oriented. Both of these are part of the PSS. So you guys are in good shape, and we're kind of making sure that all these proven technology get to PSS. These concepts are in production for years now, apply to multiple validation projects worldwide for both large system and subsystem. And we have a worldwide trained experienced AEs, know how to do the modeling, know how to make it work on real production environments. We will keep leading and be committed to support both the DSL and the C++ PSS inputs, be in Accellera and making sure that our technology is right on the spot and adhering to the standard. We will provide tools and guidance for migrating to SLN to any of the input formats if you guys wish to do so. We'll continue supporting SLN as long as needed. Cadence will enable mixes of the input formats in the same model exactly like we've demonstrated in the demo. So for more information, of course, you can join Accellera. We recommend doing that, and you can represent your company and vote for the right solution. We can represent you as well. If you want to check how PSS modeling works and how scenarios will look like for your specific challenges, if that's what you want to see, we'll be happy to assist you with all the experience we have in this kind of modeling approach. If you want to be an early adopter of the PSS approach, this is the right path to take. And of course, if you have challenges, SOC related challenges, automation, systematic approach that you want to inject into your process, please contact us, PSS_info@cadence.com. That is the email. And I appreciate the time. Thank you. And I guess I'll see you at the next video.